Good afternoon, and welcome to Chapter 5 of the Rust book. Okay, so last chapter we covered ownership and understanding ownership, which was very interesting. This chapter, we're going to be looking at structs and using them to structure related data. So a structure is a custom data type that lets you name and package together multiple related values that make up a meaningful group. Makes sense? If I'm familiar with object-oriented programming language, a struct is like an object's data attributes. In this chapter, we'll compare and contrast tuples with structs, demonstrate how to use them, and discuss how to define methods and associated functions to specify behavior associated with structs data. Sounds a lot like structs in Go. Structs and enums that we'll discuss next chapter are the building blocks of creating new types in your program's domain to take full advantage of Rust's compile time type checking. Okay, so yeah, this is really similar to how we would define these in Go. So, cargo create, we'll just say chapter 5. Cargo init, create a new cargo package in an existing cargo new chapter 5 structs. Okay. All right, so now we're in here. I think a struct should be declared external of the function. So, define a struct, we enter the keyword struct and the name for the struct. A struct's name should describe the significance of the pieces of data being grouped together. Then, inside the curly braces, we define the names and types of the pieces of data, which we call fields. Perfect. To use a struct, after we've defined it, we create an instance. Okay, let's go ahead and create a struct here. We'll just call it the user struct as defined on this site. So username, type, and then they're comma separated. Email, sign in, count, and active. Sign in count, which was a U64, and active, which should be a Boolean. Do we have a trailing comma? We do. That's so good. Okay. We create an instance by stating the name of the struct, and then add curly braces containing the key value pairs. Cool. We don't have to specify the fields in the same order in which they were declared in the struct. In other words, struct definition is like a general template for the type and the instance that fill that template with particular data to create values of the type. For example, we can declare a particular user as shown in 5.2. And I'm guessing I can do that in here. Let user equal user. And then we'll be like username. Yeah. So I'm going to just put it in the same order because I can. Terminal bash. Oh, string. So we want them to be mutable, and that makes sense, right? So string from memory, right? That from tells the operating system that we want a certain amount of memory for our heap, and it allocates it for us. And that is what we learned from ownership. Email string from the terminal bash at gmail.com. Feel free to reach out. Active is going to be true, and our sign in count will be 0. Can I do that? Yes. Okay, and now we can print. Now I was taught something on how to do this, and it was a brace colon %. I don't remember. Let's find out. User. Okay. CD to Rust, CD to chapter 5, and then we will cargo run. Unexpected token print line. Expected period semicolon. Oh. What is? I don't remember the Rust lang print macro. Maybe it's this. Oh. There we go. Okay, so now it's angry. It's expecting just that. Implement display formatted default formatter. Cargo pretty print struct. Percent plus. No, what is this? This is not what I wanted. Rust lang. I want to debug print structs and arrays. Question mark. And it's still not going to work. Okay, so I would have to derive debug on here. Okay. All right. We're going to learn more about what this does later. I'm imagining there's a... What are they called? There's a trait, and debug is the trait, and I'm saying user derives from debug, which gives it all sorts of stuff to help with this. Who knows? I don't really know. You can print with this. So what is this in Go? Sorry, Rust. Who knows? Must be some formatting. So like Rust formatting rules. Format is a macro intended to be familiar with those coming from C's printf, fprintf functions. Examples of format extensions are an illicit. Never really covers it. So, all right, I'll have to figure that out later. All right, so we've got what we want. We can see our username, email, sign-in, count, and active. It kept the order from the struct as defined, line 2 through 7. All right, so we create a struct. To get a specific value from the struct, we can use dot notation. If we want to use just the user's email, we could use user1.email. If the instance is mutable, we can change the value. Okay. Note that the entire instance must be mutable. Rust doesn't allow us to make only certain fields, mark certain fields as mutable. As with any expression, which it seems like this is since it's curly braces, and no return, and no semicolon at the end, so it's not a statement. We can construct a new instance of the struct as the last expression in the function body to implicitly return the new instance. Listing 5.4 shows a build user function which returns a user instance, the given email and username, the active field gets the value of true, and sign-in account gets the value of 1. Yep. Using the field init shorthand when variables and fields have the same name. Because the parameter names and the struct field names are exactly the same, we can use the field init shorthand syntax to rewrite build user. So it behaves exactly the same, but doesn't have repetition in email and username. Oh. Interesting. Field init shorthand syntax. So note that your parameters coming in can just map into your struct. Here we're creating a new instance of the user struct, which has a field named email. We want to set the email field's value to the value in the email parameter of the build user function. Because the email field and the email parameter have the same name, we only need to write email rather than email. Creating instances from other instances with struct update syntax. Instance from other instance. Okay. It's often useful to create a new instance of a struct that uses most of an old instance values but change some. You'll do this with struct update syntax. 5.6 shows how we create a new user instance in user 2 without the update syntax. Okay, and then with it. We just say this, and everything from user 1. Okay. The code listing 5.7 also creates an instance in user 2 that has a different value in email and username, but has the same values for active and sign-in account. Using struct without named fields to create different types. Using tuple structs without named fields. You can also define structs that look simple or similar to tuples called tuple structs. Tuple structs have the added meaning the struct name provides, but don't have names associated with their fields. Rather, they have the types of fields. Okay. Tuple structs are useful when you want to give the whole tuple a name and make the tuple be a different type from other tuples. And naming each field, as in a regular struct, would be verbose or redundant. Okay. Color and point, XYZ, RGB. Note that the black and origin values are different types. Yeah, different structs. Because they're instances of different tuple structs. Okay, each struct you define is its own type, even though the fields within the struct have the same types. For example, a function takes a parameter of type color, cannot take point. Okay. Otherwise, tuple structs instances behave like tuples. You can destructure them into their individual pieces, and you can use a period followed by the index to access an individual value, and so on. Period followed by the index. Let's play with those real quick. we want to print black.1, for example. Yeah, I didn't think that was going to work. I would expect this to work, but I'd be wrong. Oh. One day, you'll see me get it. It'll be amazing. We'll do this. Okay, these structs have to be basically everything from line 1 needs to go here and here. Now it works, and now we can print origin.1. Okay, does that work? Weird. So it doesn't have square bracket syntax. No, it doesn't. Cannot index into a value of type. Okay. Cool. Otherwise, tuple struct instances behave like tuples. Okay. Unit-like structs without any fields. Define structs that don't have fields. They're called unit-like structs because they behave similarly to the open parens, the unit type. Unit-like structs are useful in situations in which you need to implement a trait on some type but don't have any data that you want to store in the type itself. Okay. We'll touch on those in chapter 10. Ownership of struct. In the user struct definition, listing 5.1, we use the owned string type rather than the referenced string, which is a string literal, I think. String slice. Damn it. String slice type. This is a deliberate choice because we want instances of this struct to own all of its data and for that data to be valid as long as the entire struct is valid. It's possible for structs to store references to data owned by something else. To do so requires the use of lifetimes, a Rust feature that we'll discuss in chapter 10. Lifetimes ensure that the data referenced by a struct is valid for as long as the struct is. Let's say that you try to store a reference in a struct without specifying lifetimes like this, which won't work. Okay, so we've got a username with a reference slice. Do we call them those? A string slice. Email string slice, sign-in count, unsigned 64-bit integer, active is a Boolean. The compiler will complain that it needs lifetime specifiers. In chapter 10, we'll discuss how to fix these errors so you can store references in structs. But for now, we'll fix the errors like these using owned types like string instead of references like string. Okay, so it is a reference of a slice, right? So a slice is just a pointer to a specific byte in a string that's held in a series of bytes on the heap. Yeah, so it is a reference. Ampersand will always be reference. That's what I'm understanding. All right, to understand when we might want to use structs, we'll write a program to calculate the area of a rectangle. All right, so we've got a width and a height. We print them. We bring them into area, 32-bit unsigned integers, returning a 32-bit unsigned integer, calculating the area by multiplying together. Now we do cargo run. Even though this works, we can do better. And we can do better by containing them in a struct. Struct called square or rectangle with two properties that are going to be width and height, I imagine. Oh, they're just doing a tuple. Okay, so here, the issue with the code is evident in the signature of area. Area function is supposed to calculate the area of a rectangle, but the function we wrote has two parameters. The parameters are related, but that's not expressed anywhere in our program. So, with a tuple, what did we call them? Struct tuple, I think. We define, okay, so just with tuples, actually. And we just have a rectangle with a tuple, 30, 50. We bring dimensions in, unts on both of them, dimension 0 and 1, and we're good. In one way, the program is better. Tuples let us add a bit of structure, and we're now passing just one argument. But another way, this version is less clear. Tuples don't name their elements, so our calculation has become more confusing because we have to use the index. So with the struct, we have a struct of a rectangle with width and height. We then pass that into area as a rectangle, which is a reference of rectangles. So we maintain ownership in rect1, which is why we can do, well, we could print out rect1 after print line here. But then we get the width times the height, and that makes sense. Yep, that all makes sense. Adding useful functionality with derived traits. Here we go. This is what we were looking at earlier. Nice to be able to print an instance of rectangle while we're debugging our program to see all of its fields. Yes, I agree. Listing 511 tries to print it, but we're going to get an exception. It doesn't implement standard format display. Print line macro can do many kinds of formatting, and by default, curly braces tell print line to use formatting known as display. Output intended for direct end user consumption. Primitive types we've seen so far implement display by default. Okay. If we're continuing errors, we'll find this helpful. Help, the trait is not implemented for rectangle. Note in format strings you may be able to use for pretty print. It's just pretty print. Okay. Let's try this. Run the code, we get the error, so we put in derived debug. See, I could have just waited, I didn't have to Google it, but I Googled it and I found it. So we pretty print them, and then we'll see the following. Rect1 is rectangle, which we saw user being this. And our tuples, yeah, everything worked as expected. Okay. Rust has provided a number of traits for us to use with the derive annotation that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C, which I imagine is down here at the bottom. There's 20 chapters. Okay, Appendix C, derivable traits. We'll look at that a little later. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior to more closely to our rectangle struct, because it won't work with other types. Let's look how we can continue to refactor this code by turning area into a function, into an area method defined on a rectangle type, right? So, yeah, the struct is going to be able to have functions directly on top of it. What we call these method syntax. Methods are similar to functions. They're declared with the function keyword, and their name, they can have parameters and return value. They contain the same code that will run when they're called from somewhere else. However, methods are different from functions in that they're defined within the context of a struct or an enum or a trait object, which we'll talk in 6 and 17 respectively. The first parameter is always self, which represents the instance of the struct the method is going to be called on. So let's change the area function that has a rectangle instance as a parameter and instead make it an area method defined on the rectangle struct. Okay, implement rectangle. And inside a rectangle, so it's almost like a class. Implement is like a class. So it is a struct implementation. So impl rectangle, no, user. Let's get some rectangle action up in here actually. So these guys can come up here. I wish I could have derive a little bit better, but we'll say rectangle. Open this up. And this is going to be width is a U64 and height is a U64. And then we'll impl rectangle, and we'll have a function called area that takes in this, takes in a reference to itself. I thought it said this. Self, sorry. Okay, takes in a reference to itself and passes back a U, what, 32? Okay. Open this function up. We're going to say self dot width times self dot height. Okay, and we'll just return, well, it should be like that. And then down in main, we can just say print line, we'll say rectangle is equal to rectangle width 5, height 5. And then we'll print rectangle dot area. And then we gotta let this be. And then this is formatted, and it's gonna be formatted just to uint, so we don't need any special formatting. Okay. What do we get? 25. We did it. Okay. Very simple. So let's clean this up a bit. And then I'm gonna factor these out. So we're gonna create a function called calculate. I'll just call it run rectangle. Oop. Run rectangle. And it will take in rectangle as a rectangle, but we want to reference our rectangle because we don't want to lose ownership. And then that's it. And then we print it. So we could lose ownership. Why don't we do that? Let's lose ownership. And hell, we don't even need to pass anything in, right? We just define it in there, and then we just call run rectangle. Boom. And then we're going to do one called run tuples. We'll create a function called run tuples. And I'll do this. And then we'll call a function called run user. And that will do this. Function run user. Why do I keep doing that? There we go. Okay. Let's see if this compiles. There we go. Yeah. And then in each of these, we're just going to have an empty print line. Now we have some space between our functions, and our code is a little, like, the tiniest bit cleaner. Okay. So, yeah, we know that all works. To define the function within the context of rectangle, we use implement, an implementation block, and then we move the area function within the implementation curly brackets and change the first, and in this case only parameter, to be self in the signature and everywhere within the body. In main, where we call area, we pass in rectangle as an argument. We can instead use method syntax to call area. Method on our rectangle instance. Yep. In the signature, we use self instead of rectangle because Rust knows self is rectangle. We still need the ampersand before self, just as we did before. Methods can take ownership of self, borrow self immutability as we've done here, or borrow self mutability, just as they can any other parameter. We've chosen self here for the same reason we chose rectangle. In the function version, we don't want to take ownership, and we just want to read the data in the struct, not to write to it. If we want to change the instance that we've called the method on as part of what the method does, we'd use mutable self as a first parameter. Having a method that takes ownership of an instance by just using self as a first parameter is rare. This technique is usually used when the method transforms self into something else, and you want to prevent the caller from using the original instance after the transformation. Main benefit of using methods instead of functions, in addition to using method syntax and not having to repeat the type of self in everybody's method signature, is for organization. We've put all the things we can do with an instance of type in one implement block rather than making future users of our code search for capabilities of rectangle in various places. Okay. Where's the arrow operator? In C and C++, two different operations are used for calling methods. You use period if you're calling a method on the object directly, and arrow if you're calling a method on a pointer to the object, and need to dereference the pointer first. In other words, if object is a pointer, object arrow something is similar to dereference object something. Rust doesn't have the equivalent to the arrow operator. Instead, Rust. Hey Lumi, hello in chat. How you doing? We're learning Rust. Chapter 5, we're going over structs and struct methods. And we're comparing it to C and C++ and figuring out why Rust doesn't have the equivalent arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places Rust has this behavior. So how it works is when you call a method with dot something, Rust automatically adds in a reference mute, or a pointer dereference, so object matches the signature of the method. In other words, the following are the same. p1.distance reference p2, and reference of p1 distance reference P2. The first one looks much cleaner. Yes. This automatic reference behavior works because methods have a clear receiver, the type of self. Okay. Given the receiver and the name of the method, Rust can figure out definitively whether the method is reading self, mutating mute self, or consuming self. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. Very neat. Okay. Methods with more parameters. So let's practice by implementing a second method on rectangle. We're going to call another instance. So this time we want to take an instance of rectangle and return true if the second rectangle can fit completely within self. So if the area is smaller. Okay, so we want to call the method what? Can hold. All right, so let's do that. So I'm going to clean up some of this stuff. We're just going to do rectangles here. So actually, let me save and quit this. And then we'll cd to source. And we're going to copy main to points. What do we want to call it? Struct and tuples dot rust vim struct. And we're going to get rid of rectangle from here and the implementation of rectangle. And then we're going to get rid of rectangles here. And then we're going to get rid of rectangles here. And then in main Rust, we're going to get rid to line 15. No, actually 13. And then we have just that. Then we have the rectangle. Okay. And then since we're doing that, we can get rid of that method. And now we have some clean code here for you to look at. All right, so feel free to ask any questions as we're going along. I'm learning this stuff myself as well. So now we want another function, and the function is going to be called canHold. So function canHold. And we know that we want to take a rectangle in. It's going to be self and a rectangle. So we don't want to take ownership, so we get a reference of rectangle. And in addition to that, we're going to have a reference of self. I think something like that. And then we'll just say, so we need to get the areas and compare them. So, if we'll say self dot area is so greater than rectangle dot area, we're just going to return true. And if that doesn't work, we're just going to return false. Okay, so we know from that we need a return type of bool. Errors? Yeah, okay. So what's the error? Expected, types mismatch. Expected a reference of 32, found 32. Do I have to? I don't have to do that. Oh. Well, that's confusing. All right. And then we just say in main, we're like, here's the area. Can the rectangle can hold another rectangle? We'll just call it rectangle 2. and we'll pass in rectangle 2. Okay. All right, now we have errors. This function takes 0 parameters, but 1 was supplied. Well, that was my fault. Delete inside of here, and then we'll paste it. There we go. Expected a reference of rectangle, so I give it that. And then it's happy. And then we can run it, and we can see that it doesn't fit inside. Right. I think your chat window may be broken. Try reloading. It's just missed a message. Ooh. Well, got that one. You just answered the question I was about to ask. What's your programming background? C, C++? I've got a mixed programming background, so I'm self-taught. So I started with the basics like HTML, CSS, JavaScript. Then I learned PHP. Then I learned Python. I did some Java in there. I did a little bit of C and C++, but that was just for fun, not for pay. And then I learned Go, and now I'm learning Rust. So sort of all over the place. It's smorgasbord. Oh, and I also know Ruby, and I don't like Ruby. I don't know Ruby as well as I should. So yeah, sort of all over the place. I just like learning the languages. They're super fun to learn. And then they also, you get jobs and people pay you to write it. So there we go. We can see that it's fitting inside of there. So it's actually like, if you think about like how a area would work, like this box wouldn't fit because the height is the same. So I'm not going to get too deep into it because I'm not worried about writing logic. I'm just worried about understanding concepts. But unless they make me change it. Yeah, I was looking for experience in systems programming languages, specifically Rust, C, C++, etc. Anything without special treatment of memory. Anything without special treatment of memory. What do you mean by special treatment of memory? I mean, Rust is probably the least special treatment of memory I can think about with their ownership pattern. Like, you allocate memory onto the heap, and then through its ownership paradigm, it deallocates that or frees that memory from the heap for you. And it also manages your stack references and sort of disabling references that have passed their ownership on to another reference. Yeah, Go, Java, most of the other languages mentioned are garbage collected. You just program differently when you're working on system languages. I agree. And I like systems languages. I've never had an explicit need to use a systems language. Like, memory has never been that much of a concern, but at the same time, memory is always a concern. If you're ever operating on any sort of scale, like, memory is going to make itself very apparent. And you're going to want, potentially, like a systems language. I also like how strict they are. It's really, you get a set of, like, paradigms and, like, the ownership model, and you just understand the semantics, and you can write really, really clean code. But everybody keeps telling me I say that, and I haven't learned about lifetimes yet, which I'm going to learn about in chapter 10 of this book. And that apparently is a pain. All right, so we've got these rectangles. We ask if they can hold. Yeah, so width is less. Yeah, I guess that makes sense. Like, I can't just do an area comparison because it could be squashed and stretched, but I'm still going to do that. Also, Rust is pretty good, but with languages like Rust, there are a lot of algorithms, data structures, which are very hard to represent, like graphs, self-referential trees, etc. Yeah, I mean, that I don't know yet. I haven't gotten deep into that part of Rust at this point. but it seems like that would be true. Still prefer C for that. Whew, man, I couldn't get on board with C all the way. I think I learned too high level of languages at first, and C just seemed like mental punishment to myself whenever I tried to use it. But once you're into systems languages and systems programming, it's a different beast altogether, than like web development or, the IoT kind of stuff where everybody's putting JavaScript on like Arduinos or Raspberry Pis or whatever, which is just a weird thing to do. Okay, so I'm going to ignore my bad logic because who cares? I'm not writing logic, I'm learning semantics. Yeah, hate web dev. Love stuff that's closer to the system. Yeah, I mean, I do too. And I wouldn't say I hate web development. I mean, it's fine. I wouldn't be able to learn Rust the way I'm learning Rust if it weren't for web development. That being said, I would be fine with a man page. Just plop me the Rust man page and call it a day. But it's just irritating. I agree it's irritating. It moves too quick too. Like, what JavaScript's done in the last few years and all the frameworks that have come out are like a nightmare in a lot of ways. Can I just man Rust or man cargo? No. Yeah. But I got to go through all the cargo help. That's another thing is like cargo basically. Is there like a cargo docs? One thing I liked about Go was they had their docs just built right in. Yeah, doc. Build the packages and its dependencies documentation. That's pretty cool. Cargo help command. It's okay, but it doesn't help me learn like the language. So I have to go through this book. Yeah. So functions within the implement block that don't take self as a parameter are allowed. These are called associated functions because they're associated with the struct. They're still functions, not methods, because they don't have an instance of the structure to work on. You've already used the string from associated function. What specifically do I dislike about web dev? Personally, I don't like to hate on things in general, but a web dev in general moves very, very quick. Like the technology stack moves so quick. So if you rotate to, the back end for a little while, yeah, and you stay on the back end and you're doing complex problems closer to like systems problems and scale problems, and then you go back to the front end, it's like a whole new city has been built in the year that you were gone. And you don't know where anything was. The features you're using are now considered old, and people have grown new opinions on like, use arrow functions in JavaScript. But at the same time, like they still like pseudo classical, classes like with prototype. But then you have the new class syntax, but it's still just like sugar on top of prototypes. It's just really hard to keep up with all the semantics. Yeah, the old stuff still works, but you use it and then people get like oddly defensive about it. It just feels inconsistent. Well, it is inconsistent because you've got all these different browser vendors and they're all doing their own implementation of the specification, and it can change from like versions that auto update, and then all of a sudden you're getting a flow of production support issues in because Firefox isn't rendering something correctly or functionality is broken in Chrome when you did nothing. I like ES6. ES6 is great. It's more that it's shifted so quickly that you don't totally know what to use unless you've been doing front end through the transition. Oriented around JavaScript's work as a language and anything else dealing with HTML, CSS. Yeah, I mean, JavaScript's a weird language. There's no doubt about it. Yeah, coercion. Coercion is... I'm somewhere in the middle. Coercion can be okay. Like, I just don't... I don't like the way JavaScript coerces things. Like, you shouldn't be able to do a math comparison on 0 and A. Or, you know what? Let's go above, like, G, right? For hexadecimal. But, like, in reality, like, you do 0 is less than a string 1. That's coercion can happen. Like, you do that in your head anyway. It's nice to have it handled. But I do agree strict is better. Yeah, downcast and upcast are great. And just casting. Casting in general, it's not hard. You just cast it to another type and it works. Yeah. You can fix that with linters. You sure can fix that with linters. And linters do a lot. Like, I'm even using linters just in this little demonstration book I'm going through. Linters are wonderful. Yeah. I also love compile time checks. Like, Rust's compile time checks are awesome. So far, I'm digging them. Do code golfing. Yeah, I agree. Oh, Rust. Yes, oh, Rust. All right, so we've got an associated function here because it takes in size of a uint, but it doesn't take an instance, a reference, or what do we call them? It doesn't take self, a reference to self, or a mutable reference to self. Or a mutable self, I suppose. To call associated functions, we do this : syntax, which in other languages is like static call. Self, and mute self, right? Any of them. Just throw one at the method and call it a day. Like, don't worry about the ownership. It's not serious. Definitely worry about the ownership. Clippy, Rust lint collection. So if I Google Clippy Rust, what do I get? Bunch of lints to catch common mistakes. Cool. Tool for helping developing of a library. It's recommended not to include Clippy as a hard dependency. Yeah, I agree. Install Rust up. What is Rust up? There's so much to learn. There's always so much to learn. Installer for the system's programming language Rust. People complaining about web and JS is that people that complain about that rarely ever do front-end dev in other languages in settings where they need the exact same kind of flexibility and styling, layout, etc. I agree. And compared to the web is really, really good. Yeah, like if you ever done like Android development, all of a sudden you're in like these XML layout formats, and that's worse. That's like objectively worse. CSS is good, and then you've got like pre-CSS compilers that are basically like transpilers, and now CSS is getting like structured and nested CSS, so it's always getting better. It's just a matter of like browser support. And then you've got like CSS Grid and Flexbox, and those are so good. Rust Up lets you easily change Rust versions, beta stable nightly, and tool chains, cross-compilation stuff, and installing tooling like Cargo and Clippy. Interesting. So it's almost like Node Version Manager, or like a version manager, but it's a little bit more. Other forms of front-end dev can go suck it. Yeah, I agree. And I would even go so far as saying JavaScript did get its object model right. Compared to Java and C#, sure. Lisp style OOP. Is Lisp object-oriented? I don't know Lisp at this point. And I need to get through Rust before I learn another language. I think after Rust I'll learn Haskell or Lisp. No, but there are libraries for it. I wonder if there should be. Anyway, I'm not going to get into that. All right. So this is, let's see. So we've got the : function namespaced by the struct. Cool. Syntax is used for both associated functions and namespaces created by modules. Gotcha. The best OO system, but there are different kinds of implementations. Did like what it was possible because of how JavaScript handled objects. jQuery was fun because of that. Yeah, JavaScript's handling of objects is, once you understand the semantics of any language, you can see the merit in them, right? Any language that's worth its salt, and it's arguable that JavaScript's worth its salt. And then Node came out and brought V8 coupled with JavaScript onto the server. And personally, I'm not a big fan of Node, but people love it. And async await and all of these event loops and the event stack. And I get it. I just, sometimes it's fun to hate on things, right? Like, you're like, prototype. Each struct is allowed to have multiple implementation blocks. Each struct. Okay. Why? Listing is equivalent to the code shown in 5.16, which has each method in its own implementation block. There's no reason to separate these methods into multiple implementation blocks here, but it's still valid. We'll see a case where multiple implementation blocks are useful in Chapter 10. Chapter 10 is going to be jam-packed with information that like clears stuff up. Generics. Yeah, generics and traits. Got it. Coming from Lua. Never programmed in Lua. Async await people did get wrong. There are some interesting articles of instead of having an implementation based on delimited continuations, which would have made it so much more powerful. But oh well. I don't know what that means. I'm going to have to look that up. In fact, I'll add that to my notes of things to look up. JS. There's always so much to learn. When you think you know something. Wow, this is... Okay. What are they without the context? Delimited continuation, composable continuation, partial continuation is a slice of continuation frame that is... What does that say? Reified into a function. Abstract idea about a computer program is turned into explicit data model. Do we have examples? Hell, yeah, we do. Various operators for delimited continuation. I need to get into this later. I need to focus on the rest. Is this the whole chapter? Maybe I don't need to focus on the struct. Yeah. Don't try to understand it now. I know. Trust me, I know. We love distracting me. Yes. And that's okay. I like to be distracted. So, structs let you create custom types meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other. Name each piece to make the code clear. Methods specify behavior. Associated functions let you namespace functionality. Cool. Structs aren't the only way you can create custom types. Let's turn to enum feature and add another tool to your toolbox. What do you guys think? So it's 1 o'clock. Ooh, I need to plug in. 1 o'clock. I could probably do this for half an hour or a little bit more. Do you guys want to dig into the enums? I am in mountain time. Yep. I sure am. Gotta love that. Daylight savings. Enums are awesome. Sold. Okay, so let's cd over here. We're going to make a directory for chapter 6, structs. For editing's sake, I'm going to do a quick shift here. So bear with me while I line this bad boy up. We're starting enum soon. And we're back. All right, so now we're in the next episode. and the next chapter, which is going to be enums and pattern matching. Enums in Rust are actually what other languages call sum types. Okay? Really don't understand why languages always have to invent new names for things. Tell me about it. Tell me about it. I'm often thinking like, oh, well, this is a struct, which is like this in another language. Or this is an enum, but not that kind of enum. Or you enumerate, but not in the way that you're used to. Discriminated union in F#, which I've never coded in. If we're speaking of inventing new names for things, yeah. Yeah. People get excited when they're writing a language. And they're like, there's a reason they're writing a language in the first place. They're like, you got this wrong. I could do this better. And so they get creative. In this chapter, we'll look at enumerations, also referred to as enums. Enums allow you to define a type by enumerating its possible values. First, we'll define and use an enum to show how an enum can encode meaning along with data. To be fair, I don't think enum is a bad name, and some Rust enums can be layout compatible with C enums. I'll take your word for it. My C experience has been so long ago. Next, we'll explore a particularly useful enum called option, which expresses that a value can be either something or nothing. Option can be something or nothing. And we'll look at how pattern matching in the match expression makes it easy to run different code for different values of an enum. Okay, that makes sense. Finally, we'll cover the if-let construct, how the if-let construct is another convenient and concise idiom available to you to handle enums in your code. If everything in Rust, which is Haskell inspired, had the Haskell name, I feel like they'd be more confusing. Haskell inspired, I guess maybe? Maybe it is okay to differentiate. Enums are a feature in many languages, but their capabilities differ in each language. Rust enums are most similar to algebraic data